Hey, this is Dr. B, and let's learn how to identify an unknown substance. A couple of points I'd like to make. One, chemistry is the study of matter, and in its simplest form, it's in many ways just an attempt to figure out what everything is made out of. This is how you do it. So this is a fundamental part of understanding chemistry. Another point I want to make, and it's a little bit more individual in nature, is that the methods have changed a little bit. When I first studied this material in the 1970s, the textbook that we used was, I believe, Schreiner, Fusen, and Curtin, Identification of Substances. And it was a really cool, and of course back then relatively small book that allowed you to come up with methods to identify typically organic substances using nothing more than a melting point device, a spoon, a flame, and a few little chemicals where you'd look for color changes. And it was really fun to see how using such cheap devices made it possible to identify substances. But the first step we're showing here is that you better make sure it's pure. Is this absolutely essential? No, a mixture can have properties, but only if you know exactly what the proportions of each substance are. So in almost all cases, you really have to purify it. I can't emphasize enough how important this is because this is a great example of a systematic error. If you do not get the stuff pure, all these other steps are going to be just messed up. So you got to get the stuff pure. In this case, this brown solid substance is purified probably by recrystallization to a nice white crystalline substance. I wonder what it is. Well, we might as well do one of the simplest things, and that's just take the melting point, it being a solid, so we do so. We find that it melts at about 295 degrees, always report a range. D means it decomposes. That's interesting. It turns black when it melts. That's a nice additional point of information. Okay, so fine, that's its melting point. Why don't we next take its atomic absorption spectrum? This is a device that allows you to see the relative number of each element. In essence, each element has a fingerprint, if you will, of wavelengths that it absorbs at, right? It's atomic absorption spectrum. And the intensity of that absorption would be proportional to how many of those atoms are present. So if you evaluate the wavelengths and their intensity, you can get the relative abundance of each atom. I say relative, meaning that it will only give you the empirical formula, meaning that for every carbon atom, we have twice as many hydrogen atoms, and each carbon atom also contains one oxygen atom. That's relative, not absolute amounts, which means it could be C2H4O, C2H4O2, for example, but that's its empirical formula. It sounds like a fancy device. It sounds like, why do something so crazy? But hey, you can, at least back in my day, send out for like $20 or $30 to any of a host of companies, and they'd pop this information back for you using this atomic absorption device. But it would be nice to know its molecular formula, and for that, we need a mass spectrometer. That will give us its molecular weight, and there it is right there at 180 grams per mole. It does say 179, but it lost a hydrogen atom, so we add that on, and we got 180 grams per mole. If you add this up, 12 plus 2 is 14 plus 16 is 30 grams per mole. This is 6 times larger. That means that the molecular formula must be C6H12O6. And if you analyze that in terms of how many double bonds or rings it must have, we call that the index of hydrogen deficiency, you get the number 1. So this thing has either a ring or a double bond, and there's, I guess thousands of compounds that could have that structure, but at least we're starting to limit it down. What should we do next? Well, why don't we get a fingerprint of it? This is its infrared spectrum. Most organic substances absorb highly and selectively in the infrared region, and so you'll see these peaks here. Once you're trained, you'll figure out that this thing has a big OH group. It does not have any aromatic rings. It does have some alivatic stuff, and it's got this fingerprint region here. You might be able to see a C to O stretch, something like that. But to me, this says it's an alcohol. Fine, and nothing else. The fact that we got so many O's and an alcohol is OH means I bet we got a lot of alcohol functionalities, if not ethers. Finally, we're going to take the real mapping test of it. And that's the NMR spectrum, nuclear magnetic resonance spectrum. This maps out every hydrogen atom, including what the neighbors for each hydrogen atom. So this will show us every little part of the molecule. You'll learn how to interpret this as well. From here you get an unambiguous structure. And what is it? It's glucose, C6H12O6. This is how we identify unknown organic substances.